So welcome. Let's look at this. We're talking about gravity, and we're going to talk about, first of all, Kepler's laws, and then we'll talk about some things to do with gravitational force, gravitational field, gravitational potential, and then later on we'll talk about escape speed. So Kepler's laws historically, so without getting too bogged down, there was a time when people thought the Earth was the center of everything, and the person who codified that was a person called Ptolemy, and the person who publicized that, if you like, was Aristotle. Again, Aristotle was basically wrong, but and Ptolemy started off a mathematical way of predicting where the planets would be in the night sky at different times, from a model that had the Earth as the center of everything. Actually, a bit earlier, there'd been a person who'd said that the sun is the center of everything, but it just didn't seem obvious that the sun was the center of everything, because Earth's not moving, you can feel it's not moving, you see the other things go around you, you know, why on earth would you think the sun's the center? But, you know, more subtle interpretation says, well, you can't feel constant motion, so I'm not going to feel the Earth moving. It's just spinning on its axis, and etc., etc. So Aristotle had it wrong, and Ptolemy had it wrong, but actually that didn't stop them. That didn't stop Ptolemy from beginning a really good predicting model, and it got refined over the 1500 years or so that it was popular, and got really good. I mean, it was very complicated as it got better, but it was really good at predicting what happens next Tuesday. Really good. And then about, I don't know, about maybe 450 years ago, along came Copernicus. And Copernicus said that he thought the sun was the center of everything. Copernicus was a priest, really, a deacon in the church, Roman Catholic Church. If you had kids, if you were well-to-do and you had kids, then you would arrange for your daughters to marry well, and your eldest son would get all your profit, all your money, and your younger sons you'd put in the military or the priesthood, because you were too classy to have business. You could own property, but you couldn't be a tradesperson. And there was a real problem with that. You weren't allowed, in most countries, you weren't allowed to share your wealth evenly between your children, because that meant that rich families became poor as they divided up the wealth. And it was important from the social standing that the rich stayed rich and the poor stayed poor. And that's, if you read Jane Austen, that's what Jane Austen's about, is you basically, you know, sons and daughters of relatively well-to-do families, and the chaos that's caused because you're the second son or you're a daughter, and how you can just live in poverty. If you don't marry well, you will be destitute. You know, when your brother becomes the Marquis, you better suck up to your brother, because he can just cut you out. You put your kids into, I suppose, academia as well, but there weren't that many places. But the best place to put your non-heir, you call it an heir and a spare. You had an eldest son who was an heir, and you'd try for a second oldest son was a spare. If something happened to the heir, then the spare became the heir, kind of thing. And in the meantime, put them into the, you know, military, or I suppose academia, or the church, and, you know, they'll have a nice standard of living, and they'll have standing in society, you know. So Copernicus was one of these people. He basically was supported by a parish that he never really visited. He was basically never there. And they'd put all these people putting their money into the community box, and he'd get paid by it, you know. And later on, he had to go there, and he went, and he'd do like one thing a week. The rest of the time, he basically was his own, and he was an intellectual, like a lot of them were. And he liked astronomy, so that's what he did a lot of, was astronomy. And this was before the Royal Society, so people would communicate by informal letters, and he basically had his... And it was okay. It was okay to have, among that intellectual community, it was okay to have some radical ideas, as long as you didn't get up on the pulpit and start preaching it. You know, you could say, well, actually, I think the sun's the center of the universe, and the cardinal would go, well, you know, you can think that, but you're always a bit of a radical person, you know. I remember you in college, you know. I think you're wrong, or whatever. So, interest in life gets to the stage where a letter comes round. It's quite old. Letter comes round, and as it turned out, a French person was making some claims about comets, and Copernicus was just like done with it, and he sent this really scathing letter out to his friends saying this is complete nonsense and all that. And he was quite famous by then in that little community. So it turns out a very brave person who was a Protestant crossed the lines, because it was, you know, Reformation was a dangerous time, crossed the lines and said, hey, you know, you need to publish this. And you got to write this down. This is your legacy. I'll help. So he stayed, and he helped him write this manuscript. It took, you know, quite a long time. And he's writing it and writing it and writing it. And right towards the end, because the printing press had just been invented, so the first time you could publish these things, it was almost like the internet. You could communicate with a bunch of people without going through, you know, the scribes, and the scribes were pretty well run by the government or by the church. So it was a very freeing situation. So right at the very end, there was a bit of a tightening up. And this Protestant guy realized, I got to get out of here, because if I'm caught on this side of the wire, it's going to be a really bad situation. So he left. And what he did was, because Copernicus was old, he left a guy who was going to finish the job off. And sure enough, they did. And so this person is taking the manuscript to be printed, and knows it's revolutionary, and knows that it's going to cause a stir, and realizes that Copernicus is pretty well done. He's like, you know, old, but he's not. And realizes that when, you know, the trouble strikes, he's going to be the only one around who had anything to do with it, who's liable. And realize, oh man, I'm in a mess here. I'm the messenger. They're going to turn around and say, who published this? Well, you know, Bonaquisti took it to the printers. Let's burn Bonaquisti then, you know. So it's like, I don't want to do this. So on the way to the printers, he writes a page and says, this is not reality. This is just an easier way of mathematically calculating what happens next. Ptolemy's method is so complicated. This is a simpler model. It's an easier mathematical model. Even though everything goes around the Earth, if you assume everything goes around the sun, you get a simpler model. And gets it printed. And takes the copy back to Copernicus. Copernicus is beside himself. What's all this nonsense in this first page? I believe every word I wrote. The sun is the center of the universe. So he's angry. And he dies quickly. And the guy's kind of going, oh, thank heavens. Because it turns out nothing happens. No one cares. Because it turns out that when you do the math using Copernicus's model, it's awful. It's terrible. It can't predict anything. So yeah, you bet it's just a mathematical model, and it's an awful mathematical model. Simple models give simple answers. And so, yeah, this is not aggressively, this is nonsense. So it's ignored. If you only get into trouble if you do something that's revolutionary and it has an effect, you know. So, But it sets in motion these ideas, and later on comes Galileo, who looks at Venus and realizes that the only way Venus can have the phases it has is if everything goes around the sun. And he looks at Jupiter and sees Jupiter has moons going around it. And so Aristotle's got to be wrong when he says everything orbits the sun. That thing's orbiting Jupiter. And what had become, Aristotle's ideas and Ptolemy's calculations became dogma for the church. And you upset that apple cart at your own risk. And Galileo made the mistake of he was friends with a cardinal who became the Pope. And so he thought, yeah, that's Bill. I know Bill. I'm going to be fine. Wrote his book. Galileo was probably not the nicest guy out. He'd been at loggerheads with a few powerful people, and one of the things he did was he wrote his ideas as a dialogue. Basically, an intelligent person, Galileo, though he didn't call himself Galileo, and this cardinal, who, although he doesn't name him, everybody knows who it is. Everybody in the family knows who it is. And the cardinal comes across like a fool. And so the cardinal reads this and says, that's me, And, payback comes back. The cardinal works out a situation whereby through powerful clergy, through powerful lay people in the church community, he makes it so that the Pope has to take action, or the Pope has to accept the fact that people are allowed to go against holy order teaching. But the Pope's never going to do that. So it ends up with the Inquisition. Galileo shown the instruments of torture and said, do you still think that's right? Galileo says, well, no. And house arrest for 10 years, which was great because he did an awful lot of physics. Maybe that's the way you should just put, when you go to college, it's just house arrest for 4 years. And then you can socialize at the end of it. I don't know, maybe that would work or we'd all go crazy, I don't know. But very productive time for Galileo. Okay, so Galileo has his ideas. And then along comes Kepler. Kepler's an astronomer who he doesn't use telescopes. Remember, Galileo basically perfected the spyglass into a telescope and revolutionized astronomy. Kepler's a bit old school and he's measuring the angle between planets and stars, and that's what they did. That's what astronomy always was. Why? Because why would people spend their time measuring the angles between planets and stars? Because there's money in it. Why is there money in it? Because they're going to cast horoscopes. This is nonsense. This is astrology. Yeah. Galileo taught astronomy in college to medical students so that they could cast better horoscopes. I mean, that's the truth. So astronomy and astrology were linked very closely until about 150 years ago. But Galileo taught astronomy so that people could do astrology. No question. Ptolemy, 3 books. One was on astrology, one was on astronomy, and one was on something else. I don't know. Very intertwined disciplines. So Kepler's earning his living by casting horoscopes. Now, I don't believe in horoscopes. I mean, there's occasions when, I go, oh, I didn't see that coming, but, the evening newspaper did. Look, I will get presents from people. Who'd have thought that would have happened, in December kind of thing, But, you kind of go. And I know some really bright people. I was at NC State. One of the brightest people I knew asked me when I was born. I told them. And it turns out I know when I was born. I know where I was born quite precisely, because it was a family joke. I was born at 15 minutes before noon on this date in Leeds, because I was, I was born hungry. Apparently, at one stage, I had the record for putting on the most weight of a newborn in St. James's Hospital. You know, for a few years, I was the record holder because I just put on weight like crazy. So it was always a family joke. So I knew exactly when I was born. So they said, "Oh, that's amazing! I can do a horoscope for you." And I'm going, "Oh yeah, sure. You know, do you want me to do it? Oh yeah, why not? You know." And then 3 months later, they came back with the smallest handwriting I've ever seen in my life, and this classical calculation of my horoscope based on the planets and everything. And I was speechless. I was thinking, what am I going to do? It's like, so I said, "Oh, thanks ever so much." I took it home and I read it. I read the first couple of pages, and it was like I couldn't follow any of it. It was like, and at the back of my head, they're going, you're spending your time reading something which is complete garbage, you know? So I put it away, and I didn't say anything, and they didn't say anything, and then, you know. And then 6 months later, it must have been, they said, "So what do you think of the horoscope?" I said, "Oh, it was very interesting." And it kind of, so I went back and tried to read the whole thing, and I'd lost the second half of it. So I was like, I felt so bad. I felt bad because they put so much work in it, and I'd been so, in a way, disrespectful. Because even if I don't believe it, they still, just the intellectual exercise they'd done. I'm not sure they believed it, but they did it, you know. That's how he earned his living. He earned his living by doing stuff like that. And it's not trivial. It's not like, you know, oh, the moon is here, then you're going to be, like, you know, happy. It's like the people who believe it in great detail. I don't, and so it's not unreasonable to me that every now and then this guy would cast a horoscope and it would be a disaster. So should I go to war with my neighbor? I say yes, we go to war, it's a disaster. You know, I'm kicked out. Even if my Lord and Master survives, I'm kicked out. So these people tend to have lives where they did that, and then they'd cast a bad horoscope and get kicked out. They'd go somewhere else and cast a bad horoscope and get kicked out. It's like, do we have the same thing today? It's like Bill Gates as a resident comedian, or Bill Gates employs somebody who comes to dinner parties and entertains, but is also useful. It's that kind of thing. There's not quite the same thing here. So Kepler was kicking around, and he ended up in basically an island off the coast of Holland, and continued his work. He kept trying to work out what the mathematics of the universe was, meaning the solar system, basically. And the way that I'd imagine that is, I mean, think about it. We now know that he is on a spinning planet. He's on a spinning planet looking at things that are revolving and spinning around something else. You know? I mean, this is like a really difficult thing to do. It's like going to Disney and going on the teacup ride and turning all the lights out so that you can't see the room anymore, and wearing these little headlights and looking at all the spinning and working out the mathematical expression for that machine. It can be done, but I can't do it. And neither could Tycho Brahe. And he employs, I'm sorry, I think I said Kepler before, it's Tycho Brahe. And he employs a series of assistants, and none of them can really do it. He's a bit tight with his data. It's his gold mine, so he's not going to share it. He'll give you a little bit. And he's given Kepler Mars, and he's making some headway, and then Tycho Brahe dies. And Kepler's like got all the data. And he comes up, it takes him about 10 years, but this is what he comes up with. He recognizes that all planets orbit the sun in an elliptical path where the sun is at one focus. And then the next logical question is, well, how fast does it go? And he finds out that the planet sweeps out equal distances, equal areas of space in equals amount of time. Now, we can appreciate that from an energy point of view. Here it's got a lot of potential energy, and here it's got a little bit of potential energy. So here it's not got much kinetic energy, and here it's got a lot of kinetic energy. You know? And then not only did that, he went to the next stage, and he was able to recognize that the mathematical relationship, the period squared is equal to some constant times the radius cubed. What radius? The average radius. We kind of cheat. It's really the semi-major axis, but we'll call it the average radius. Okay? Good. So it took him about 15 years to get that out, but there's his 3 laws. So the first law is all planets move in elliptical orbits with the sun at one focal point. Second law is a line drawn from the sun to a planet sweeps out equal areas in equal time. And the third is the square of the orbital period of any planet is proportional to the cube of the semi-major axis of the elliptical orbit. This first point is actually quite instrumental. Copernicus had a lousy model because of a detail. He thought that although the sun was the center of the universe, all the planets went around the sun in circular orbits. And why did he think that? He thought that because a divine creator would work with divine structures, and a circle is a special kind of ellipse. It's this idea about, you know, the Greeks thought in terms of spheres. Everything's spherical. It's pure. Potatoes are not pure, you know. Copernicus thought the circular orbits, because if you're going to make this kind of thing, you're going to use this elegant structure. And we're wired for it. When you're raised in that kind of tradition, you're wired for it. So just to give you an example, Newton, all those years later, probably just a bit later actually, but Newton made 7 colors for the rainbow because he wanted 7 colors. If you look at it, red, orange, green, blue, indigo, violet. What's the difference between blue, indigo, and violet? I mean, I have no idea between the indigo and violet. My daughter was learning red, orange, yellow, green, blue, purple. And I was going crazy about, no, it's indigo, violet. And then I thought about it and said, well, I don't know what the difference is. So I looked at it. I looked at the spectrum to see, is it that it's 7 divisions in terms of wavelength? And it's not. There's no reason why it's indigo or violet. And then you read the history and it turns out that Newton believed he wanted a sacred number for the number of divisions. So he divided it into 7. We talk about lucky 7. Lucky 7's your lucky number. That's steeped in history. That is one of those weird cultural things. And Newton was subject to it. And it leads you off a cliff very often. And it led Copernicus off a cliff. Why should it be? He never questioned, should it be circular or elliptical? He said it's circular. Of course it's circular. It's wrong. Lousy model because of that. So we've got to be careful of it. You've got to be careful of your deep-seated assumptions. Anyway, so basically this is really good stuff. I tend to ask definitions, and I tend to ask this. And this, okay, how long does it take us to go around the sun in years? How many years does it take us to go once around the sun? 1 year. How far is our average orbit from the sun? 1 astronomical unit. So 1 Earth year. If I have 1 squared equals some constant times 1 cubed, that constant equals 1. So if you're dealing in Earth years, and if you're dealing in astronomical units, that's the distance from the sun to the Earth's average orbital radius. That constant's 1, and that's what I ask you. So let's do an example. What would be the orbit of the Earth in Earth years of a planet that is 7 astronomical units? So this is 7 AU. So I say T squared is equal to K times R cubed. So it's not T squared is equal to 1 times R cubed, 7 cubed, which is going to give us that T, let's just cut to the answer. So T is equal to the square root of 7 cubed. So let's have a look. 7 caret 3, enter. Second square root, second answer. Oops. Second answer. Can I save it? No. Okay. 7 caret 3, enter. Second square root, second answer. That's going to be 4.3. So 4.3 Earth years. So it's simple. By the way, just by the way, how far away is Neptune from the Sun in Earth years? We are 1. So here's the Sun, and here's Earth, and we are 1 step away. How far away is Neptune? Is it 5? Who thinks 5 or less? Who thinks 12 or less? Who thinks 15 or less? Who thinks 20 or less? You're going to have to put your hand up sometime. Who thinks 25 or less? Who thinks 30 or less? Who thinks 50 or less? Never had this before. Who thinks 100 or less? All right, what do you think? What do you think? What do you think? So if we're 1 step from the Earth to the Sun, how many steps is it to Neptune? What do you think? 1,200. Whoa, okay. I mean, you can see Neptune with a telescope. Yeah. Sure. What do you think? 500. What do you think? 7. What do you think? 60. No, you can't have no clue. That's an English thing. That's a language arts. What do you think? Pardon? 200? Okay. Yeah, you got to pick. It's 30. It's not that far. It's 30. Most classes, I can fool them. If I just go in 2s, they go always going in 2s. So I'm going to pick something like it's 3rd or 4th choice. Saturn, Jupiter is about 5 away from the Sun, which means it's 5 times further away from the Sun than we are. Neptune is 30 times further away. So think about it. From light intensity, Neptune has 30 times greater, 1/900th the intensity of sunlight on Neptune. So the Sun is 1/900th as bright on the surface of Neptune. It's not a very bright planet. So for period, so the period is equal to the square root of 1 times 30 squared, which is the square root of 3 3s cubed, sorry. So that'd be 3 3s are 9, 3 9s are 27. That's 27 times 10 to the 3. So the square root of 27,000, second square 27,000 is equal to 164. So it takes 164 years for the Earth to go, for the Neptune to go around the Sun. So in my lifetime, I'll be lucky if I get halfway around the orbit. You know, it's very much longer than a human lifetime for it to go through. Which I suppose is why some generations have a lot of bad luck throughout their life. And other generations have really good luck throughout their life, because astrologically speaking, that is a very significant, if you believe in astrology, that's the thing. So I'm going to stop there, because I want to tell you one more thing. That